Hello everyone and welcome to this video. Today we are going to be learning about manipulating and comparing arrays, and in this section of Numpy we are going to learn about arithmetic operations we can use on different arrays. Now, as I told you, we are going to be learning about manipulating and comparing arrays, and we are going to be learning about how to perform different arithmetic operations. Okay, so let's start to launch our Jupyter notebook. Okay, so I'm gonna close this. Okay, so you first you need to search up Anaconda prompt if you're in Windows, or you need to search up terminal if you are in Mac OS or Mac OS X or Linux. So I'm just gonna make this bigger. So first, just a quick reminder: if you have not set up your environment yet, please do so, because the commands I'll write won't make sense and they'll throw you an error. So please follow the steps before you actually start launching. So the first thing we need to write is Conda activate. So we're telling Conda to activate our environment. My environment is in users, Venka, desktop folders, ML course. So you can press tab to autocomplete. Practice project. So if I zoom out, actually, practice project and env. Okay, so that if we press enter, this base has turned into this over here. So now I need to type in Jupyter notebook. Whoops. Okay. Okay, so for some reason it's not letting me do anything, but okay, so once we type in Jupyter Notebook, we press enter, and it'll come up with some links and everything, and that means it has started to load. So here it'll come with these links, and now it should come. So we'll just wait. Okay, so now it has come. Now, as you can see in the Anaconda prompt, we have this. So we need to navigate through this path over here. So that is what we are going to do. See you when I have done that. Okay, so here is the notebook from last time. Here is where we left off last time, and we learnt about how to view arrays and matrices, and about how to index and slice them. Now today we are going to learn about what was it again? So this is our fifth lesson. We are learning about manipulating and comparing arrays, and also today we're going to learn about arithmetic methods. Okay, arithmetic methods. There we go. So today we are learning about manipulating and comparing arrays, and in this particular section we're learning about arithmetic methods. So if you list all your arithmetic methods, there is there's plus, minus, times, and divide. Okay, so there's plus, minus, times, and divide. I really can't. I'm not going to type down divide, but you should know that. but in Python they display it differently. So let's bring in one of our arrays. So A1, this is an array we created earlier. It is this array over here. We also have ones, which is another array, but we are going to recreate that. So let's say ones is equal to np.1, so it will create an array full of ones, 3. And then if we call ones, beautiful. Okay, so let's see if we can add A1 and our ones array together. So A1 plus ones. Okay, so what has this done here? Basically, if we view A1 and ones, now we have all of this over here. So what has it done? So this 2, what is this 2 representing? Okay, so this is 1 plus 1.0 is equal to 2.0. But let's just reference 2 as 2. 2 plus 1 is 3. 3 plus 1 is 4. Okay? So this is what it gave us. So how about we actually try to how about trying to subtract them? Yeah? Okay, so what do you think this will give us if we subtract it? So let's see. Let's say A1 not plus minus ones. Okay, so what has this given us? So if we look at A1 and ones, it is basically 1 minus 1 is 0. So 1 minus 1 is 0. 2 minus 1 is 1. 3 minus 1 is 2. Okay, so that is what it is. We can also times them together. So what do you think this will give us? A1 times ones. Okay, so let's view ones and A1 together so we can see. So 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. Okay, so simple. So now let's bring in A2. This is another array. So this time it has 2 rows. And A1 has 1 row. So let's see what will happen. So if I say A1 times A2, what do you think this will give us? Have a think. I'm going to run it now. Okay, so this has actually given us an array with 2 rows. Now, what does this mean? So basically, what it has done is 1 times 1 is 1. 2 times 2 is 4. 3.3 times 3 is 9. Okay? And then it has gone 1 times 4 is 4. 2 times 5 is 10, and 3 times 6.6 is 19.8. If you're unsure if that's correct or not, you can just work that out. So you can say 3 times 6.6. Okay, so that's just giving us that. So what we're going to do is we are going to put brackets around that and use the round method. Okay, so right now we get 20, but if we round it to 2, actually, we get 19.8, okay? So 19.8, and that is exactly what we got here. So if we don't really need this cell right now, so we can delete that. So esc and esc and x, and it will be deleted, okay? So now, since we have done A1 times A2, let's bring in A3. Okay, so now we can try A3 times A2 times A3. So you can try this. Whoops, what just happened here? A2 times A3. What will this give us? Oh, it's giving us a value error. So it's saying operands could not be broadcast together with shapes 2, 3, and 2, 3, 3. Okay, so why is this doing this? So basically these have two different shapes. So let's look at what broadcasting is. Now this is a perfect time to go and open up, to actually go and open up and say Numpy Broadcasting. Okay, so here it's saying broadcasting Numpy v1.19 manual. So we click that. Okay, so here here it says the term broadcasting describes how NumPy treats arrays with different shapes during arithmetic operations. Okay, so let's look at the example. Here it says A is equal to NP array, and they create this array, okay. B is equal to NP dot array, and it has this. So they both have the same shape. So if we do A times B, that is going to work because these two arrays have the same shapes. Okay, so again, we can say we can also do this. So we can have a array. We can have this array and times this by another number. It will be relaxed. Okay. So here are some general broadcasting rules. When operating on two arrays, when operating on two arrays, NumPy compares their shapes element-wise. It starts with the trailing dimensions and works its way forward. Two dimensions are compatible when they are equal, or one of them is 1. If these conditions are not met, a value error could appear, and it says operands could not be broadcast together, which is exactly what happened with us. Okay, so have a you might have a go at thinking about have a go about thinking about how can you reshape this A2 array over here. So if I just write a cell, put this in markdown, have a think. How can you reshape A2 to be compatible with A3? Okay, so have a think about that. Okay, how can you reshape A2 to be compatible with A3? Okay, and here is my hint for you. So search here you can, so here's my hint. You can search up search how to reshape a NumPy array. Okay, so search that up and hopefully it should come up. Okay, so have a go at trying to reshape this NumPy array. For now, don't worry if you don't understand because I'll cover this in a future video. So don't worry if you don't know. For right now, I'm just gonna continue with more mathematical operations because I want to just finish this video up. Okay, so let's just use A1 and 1s again. So what I'm going to do is I'm going to write down A1 divided by 1s. Now this slash is equal to division in Python. So if you do this, okay, so we've got 1. So 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. Okay, so hopefully you understood that. Now we can let's try with some floor division. So A2 slash slash, so this is floor division, divided by A1. So so what is the difference between floor division and normal division? So basically floor division rounds all the results. Okay, so it rounds all the results. So we can also say A2 divided by A1, but if we don't want too many decimal places like this, then it'll just round it for us. So let's actually look. So let's view let's view A1, and let's also view A2 and work out this calculation. So 1 divided by 1 is 1. 2 divided by 2 is 1. 3 divided by 3.3 is about 1.1. So it rounded it to 1. 1 divided by 4 is 4. 2 divided by 5 is 2.5, and 3 divided by 6.6 is 2.2. So you can work that out. So 3 divided by 6.6, and we round. If we round this, it should probably give you the answer. So now that we have learned about some floor division, we can also square this. So I'm going to say A2 to the power of 2. So these two asterisks mean to the power of. So A2 to the power of 2, it has basically squared each of these numbers. So 1 squared is 1, 2 squared is 4, 3 squared is this, so on and so forth. Now, NumPy also has its own methods for all of these arithmetic methods you can use in Python. So you could say np.square and put in A2, and it'll give you exactly the same results. You can also do this with adding, so I can say np.add. So np.add, and let's press Shift Tab to see what it does. Okay, so what does it do? It adds this. So what arguments do you need to put in? The arrays to be added. Okay, so I want to add A1 and 1s together. Okay, so this is exactly the same if we do A1 plus 1s. Okay, so it has given us exactly the same. So there are loads of other methods. You could go ahead and check out those on the NumPy official documentation if you like. So there is also a method called modulo. So you could say A1 modulo 2. And this just gives us this. So it actually kind of looks really confusing. So if we open this up and say, let's say actually not A1, sorry, NumPy Modulo. Okay, so numpy.mod, we look at the manual. So this says return element-wise remainder of division. Okay, so so it's basically, so the parameters, we want the array to be divided, and we've also got the other one to be modded by. Okay, so this actually kind of looks confusing, but all it's trying to tell us is it's just so if we view A1, what it does is it does 1 divided by 2, and then it gives us the remainder. 2 divided by 2 gives us the remainder. 3 divided by 3 gives us the 3 divided by 2 gives us the remainder. Okay, so that is what it does. So there is a method for this. So we could say np.mod shift tab, and it's basically it returns the element wise remainder. So which one do we need to put? What do we want to mod? A1. We want to mod it by 2. So it gives us exactly the same. Okay, so we can also do this by A2. So A2 mod. So I'm going to say mod for now. A2 mod 2. And it gives us the all the remainders. So if we look at A2, 1 divided by 2, remainder of 1, 2 divided by 2, remainder of 0, 3.3 divided by 2, remainder divided by 2, remainder of 1.3, 4 divided by 2, remainder of that, and so on and so forth. Now there are also some extra methods. So there's np.exp. So this returns the exponential. It returns the exponential of each element in a NumPy array. And np.log. It also does another thing. Okay, so try and check out. I'm giving you this exercise. Try to check out this on what this does. Play around with it, and also don't forget to try do this. Okay, trying is important. If you don't get it, don't worry. I will teach you this in a future video. Okay, so I hope you guys really liked the video. If you did, thank you for watching it. Please like and subscribe if you like the video. If you have any comments or doubts, please put them in the comment section below. So, I guess that's the end of this video. Bye!